Okay. I actually think it is streaming, but all right. Not sure exactly if we're back. I think we are kind of. So I don't know what happened there. It's never happened before. So I don't know what's going on. But it's having trouble today. Anyway. Well, I see a couple of people found it. So that's good. And it's going to be, I'll piece them back together so that they're actually one thing when we get back to it, once I get done with it. So what we were doing is recap. We were trying to get the X component of force AD. And eventually we want the X, Y, and Z of all three of these force components. Oh, good. Somebody did say it's actually back up now. Good. So how we're going to do it, since none of these forces are guaranteed to be in a coordinate plane, X, Y, Y, Z, or ZX, then we're going to, create our own planes. And what I was saying is that we're going to use the definition of cosine. We're only going to use cosines for this. Let me scroll so I can write the definition of cosine. So cosine of some angle is equal to the adjacent side over the hypotenuse. So remember, we just spent a couple of minutes finding the length of all the force vectors. In this case, not the length of the force vector, the length of the actual element, so the cable or the strut or whatever it happens to be, and that's these numbers here based on their end point coordinates. And that's the hypotenuse of, in this case, I'll try to isolate the thing we're talking about here. So here's the force we're dealing with. We want to project it onto the x-axis, and so we've kind of created this tilted plane, and we've got this alpha angle that I've drawn. So cosine of alpha equals the adjacent side, which is the x component, in this case, of AD. Maybe I should put AD x component. Over the hypotenuse, which is AD length. And the x component is right here. 0. We have the x coordinate of it, so it's 0. X coordinate of AC is -5. X coordinate of AB is 1. And we have the length of AD. The length of AD is what I called L1 over here. So, in other words, the cosine, go to the right page, the cosine of alpha for this x component, we can just use the definition, the actual definition of the thing, which would be 0 for AD over whatever the length L1, whatever L1 was, like 5.3 inches or something, or 5.3 meters. I didn't put units on it. And if I have that cosine of alpha, remember, what I ultimately am trying to do is write equations like this. TC, so in this case AD, times the cosine of alpha minus AB times the cosine of its alpha or beta or whatever we want to call it. We won't have enough variables to name each one of these their own angle, right? Because each component, X, Y, and Z, gets its own angle between that axis, X, Y, or Z, and the force component, and there's 3 force components, so there's 9 different angles. So let's try to assemble this. It might take you a while to wrap your mind around what we're doing, but I think if you keep in mind that what we're ultimately trying to do is write the summation of forces in the x direction and the summation of forces in the y direction and in the z direction that it will come through once we get it all kind of assembled. So I'm going to do this in MathCAD. So, or should I do it on paper first? Maybe I should do it on paper because I'm going to need to write it out, and we'll do it on paper. Well, not paper, on here, screen. We're going to take this idea and write summation of forces. Let's do the x. So the equation I want to write is, I'm not going to use negative signs. I'm going to only use positive. Remember, when you do the cosine and you measure from the coordinate axis, x, y, or z, then when you calculate that cosine, it will include any necessary negative signs or positive signs. So I'm not going to write any of these as negative, even though clearly AD is going off in the negative y direction. I'm not going to write it that way, except for the fact that I'm going to put a -5 in there. But what I want to do is, in the x direction, let's just write out this equation that I want to generate. Summation of forces in the x direction equals 0, I guess equals AD times cosine of alpha, I drew it as alpha, plus AB, no, I did 2 as AC. So AC times cosine of, we'll do beta, and beta, I can't even draw beta, but it's the, well, I kind of can. It's the distance, or not the distance, the angle between AC and the x-axis, so that beta, and then the angle between AB and the x-axis, we'll do that one as gamma. So we'll just write this one with alpha, beta, gamma. So plus AD, wrote my other A's the other way, AD times cosine gamma. There's no external force in the x direction. There is an external force, but it is wholly in the z direction, so I don't have to, write it in the x equation. So equals 0. So that's the equation I want to create. So I'm going to set this up as the same type of matrix that I had when I did the 2x2 right here. So well, really more like this one, where I have the coefficients in this matrix. So the coefficient, so this first column is going to have all of the things for AD. Second column will have all the things for AC, all the coefficients. The third column will have all the coefficients for AD. This first row will represent the summation of forces in x direction. The middle row will represent the summation of forces in the y direction. And the bottom row, summation of forces in the z direction. So you don't have to do the top row is x, the second row is y. You don't have to do that. Just the rows have to be all x components. And the columns have to be sorted by the variable, even if there's a 0 in there, which we start out with a 0, right? Yeah. So the thing that goes in this spot is this guy, cosine of alpha. The AD, the variable name, is actually going to be over here. So AD, AC, and oh, wait, I did AD twice. Which one did I label wrong? This is supposed to be AB at the end. Sorry. Okay, so the coefficient that goes with AD and the x is this cosine of alpha. Cosine of alpha is the adjacent side for this force over its hypotenuse. So that is 0 is the x component over L1, or the length of AD, which is 5.4. Get back over there. or you could put L1 in there. So this coefficient is actually just 0. AC, I need the cosine of beta, so the x component for AC was a -5. The length of AC I called L2, and that is 7.3. And notice how this one gets the negative sign for this term from the -5. So remember, the -5 over 7.3, that is cosine of beta. And then AB would be cosine of what I called gamma, which has an x component of 1, and a length for L3 of 5.5, we'll call it. So these numbers, 0 over 5.4, that's just 0. That's the cosine of alpha. -5 over 7.3 is the cosine of beta. 1 over 5.5 is the cosine of gamma. And we do that for each one of these things. So now for y, it's not alpha, beta, and gamma anymore. Now, the y-axis, I'm not going to be able to draw all of these, but I'll draw this one, and hopefully we get the idea, is the AD, that's the one that we're working on right now, angle between that and the y-axis. So whatever you want to call that angle. Eta, or whatever you want to call it. And so that is in a plane that's kind of tilted towards you, right? So if you took the YZ plane and tilted it towards you a little bit, wait, no, not towards you. No, that actually is the YZ plane, because this does not tilt towards you. This is literally the YZ plane. So x of -5, had the cursor on the wrong spot, for the y component. Same length as before, so over 5.4. And that negative sign shows you that this thing is kind of pointing off towards the left. -5, they all have -5 for their y components, right? -5 for AC, -5 for AB. So they all have a -5 there. They have different lengths though. And then to create the z, we take the z coordinates, 2, -2, and -2. And they're over the lengths of the respective AD and AC and AB. Oh, not 5.4, 7.3. And then the other part, the last part that we don't have when we've written out our equations, is equals. And we have 0 force in the x direction, 0 force in the y direction, and a 1,125 Newton force in the negative z direction. But when we move it to the other side of the equal sign, like I have here, it becomes positive. So this is the set of equations in matrix form that I want to solve. So to solve them, AD, AC, and AB, that matrix, equals the coefficient matrix. I don't want to write all of those in again. All of those raised to the -1 power, so we need to divide it basically, times that. And then, these are all filled in. So that's what we're going to put into MathCAD, is this guy. All right. So in MathCAD, I've got all these variables set up. So I need my keyboard. Make sure MathCAD is on the screen. So I need x1 over L1. I need y1 over L2, or y1 over L2. No, I need x2 over L2. Sorry, I'm getting confused there. Because this row should all be x components. x3 over L3. And then we need all the y. We did y's in the middle row, so y1 over L1, y2 over L2, and y3 over L3. And then our bottom row, we did the z's, z1 over L1, z2 over L2, and z3 over L3. We need to raise this whole thing, to the -1 power, and then multiply the whole thing times a new matrix. Control M creates matrices in this version of MathCAD. 0, 0, and 11, 25. Again, I'm leaving the units off just because I didn't put units on any of these. And it should equal a matrix with 3 numbers in it. 15, 15, so 1,515 pounds. These two did come out negative, which is, remember from the beginning, we were okay with that because it does look like AC and AB should be negative. I don't know if I pointed it out, but so the order, whatever column you use here, so I used all the AD coefficients, that column is, going to be the first number that comes out of your variable, the answers. And whatever you put in the second column, all of those coefficients, so that's why it's all the AC coefficients, that comes out in the second spot. And the third column, all of those coefficients are lined up, and that variable comes out in the third spot on this matrix. So AC and AB, the two struts, AC and AB, did come out to be negative numbers, which we thought they should be because we drew them as going away from the body, which would mean tension, but they're actually in compression, which should point towards the body. I guess I should check, that's a little scary, but I should check to see if WebWork actually agrees with these numbers. Let's see. Are they in the same order? AD, AB, and AC. Oh, gotta log in again. Yeah, those are the same numbers. Now, they didn't bother to put the negative signs on these two, which they should have, but I guess that's fine. But they technically are negative forces the way we drew them anyway. So WebWork doesn't seem to care in that one instance if they were positive or negative. But they are compressive. So hopefully that helps kind of wrap your mind around where this is coming from, where these matrices are coming from. Again, you don't have to use this process, but you do have to generate these equations. These are just equations split apart into their components, put into these matrices so that we can solve them simultaneously. And if you want to solve some other way, then the equation is like this top row. That is the summation of forces in the x equation, in the x direction equation. You would have to have AD, AC, and AB also, to multiply by the 3. I don't know how much of matrix math you've done, linear algebra type stuff you've done. So you may not be familiar with exactly how the matrices multiply together. I don't know how much of that part you know. But all you're doing is creating a system of equations, and you're carefully crafting it so that all of the variables, all the coefficients for one variable are in a column, and the next variable are in the next column, and the next variable is in the next column after that. And even if you have zeros for some of your coefficients, those are also accounted for in the matrix. You can't leave anything just empty, or you can't move things around. That really messes it up. So you have to account for even empty zero spots. Okay. Don't know why the stream went kind of crazy on us. It's never done that before, but maybe something's different today. But I'll piece these two back together, so if you want to go back and watch it, or maybe you haven't watched it, maybe you're watching it now, and maybe you'll never know that the stream kind of did some weird stuff on us. What I would recommend, let's check out the web work. we're wrapping up here. So here's what you've got coming up. Homework 1, you've got a couple more days to work on. Homework 2, I've went ahead, that's covering the 3D stuff. And I've gone ahead and opened homework 3 just so if you want to, you can start on it, but we won't talk about it until Wednesday. So things start to pile up if you don't stay ahead of these. The challenging one, they stay open until exam 1, and the optional one also stay open to exam 1. So you got plenty of time, much more longer time, the 24th anyway, so not that much longer, to work on those. And the optional, they're just optional extra practice. The challenging can get you extra credit. So basically, challenging 1, it can give you 1 extra final grade point. If you got all of challenging 1, it would give you 1 extra final grade point is what it amounts to. Challenging 2 would be another one. Challenging 3 would be the last one. So if you did every piece of web work and the challenging, the HW ones, and the 3 challenging ones, instead of making a 10 for your homework grade, you'd make a 13, if that makes sense, on your final grade. All right. And the optional, they don't go into bonus. They're just for practice. I'll leave the chat open for a little bit if there's any questions. We're actually a little bit early, but that's okay. And I will try to fix these 2 different streams into one thing so that they look better on if you watch it later. I'm not sure why I did that. All right. I will come back Wednesday. We'll start doing our mechanics part of things. So it'll become statics and mechanics of materials finally on Wednesday. This stuff should be probably new, the 3D part of it anyway, so work on that. If it seems a little bit confusing, ask questions. There is at least 1 3D problem on exam 1, so you do need to know how to do this for exam 1 at least. So that's roughly 6-ish points on exam 1 will be one of these guys. All right. I still don't see any questions in the chat, so I will come back on Wednesday and see y'all then. Bye.